Hello friends, and welcome once again to my YouTube channel Engineering Physics by Sanjeev. This is a new MCQ series on electrodynamics. Hope this MCQ series will help you in preparation of different competitive exams like MHTCET, JEE Main, NEET, etc. If you like it, please subscribe to the channel and share with your friends. So let us start with the first session, MCQs on gradient of a scalar function. Here is question number 1. The mathematical perception of the gradient is said to be, the options are tangent, chord, slope, arc. Friends, gradient of a scalar function is a vector and it points in the direction of maximum change of the function. And the magnitude of gradient of the function gives us slope, that is rate of change along this direction. So the mathematical perception of the gradient is said to be a slope. So here C is the correct answer. Let us move on to the next question. Gradient of a scalar point function phi of xyz is, these are the options given here. We know when del operator I cap del by del x plus j cap del by del y plus k cap del by del z acts on a scalar function, then we get gradient of that scalar function. Therefore, gradient of phi is equal to del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. This is given in the option D, and therefore option D is the correct option here. Next one, the magnitude of a gradient of a function f is equal to xyz square at 0.102 is, the options are 1, 2, 3 and none of these. Here we will have to find the gradient of this scalar function xyz square. To find the gradient, we will make del operator to act on this scalar function. So gradient of f is equal to del f by del x I cap plus del f by del y j cap plus del f by del z k cap. Here f is equal to xyz square. So when we differentiate xyz square with respect to x, we will get yz square. When we differentiate xyz square with respect to y, we will get xz square, and when we differentiate xyz square with respect to z, then we will get 2xyz, and therefore gradient of this function f is obtained as yz square I cap plus xz square j cap plus 2xyz k cap. Now we want to find out gradient of this function at point 102. So let us put x is equal to 1, y is equal to 0 and z is equal to 2. So when you substitute x is equal to 1, y is equal to 0 and z is equal to 2, we will get this gradient of function f as 0 I cap plus 4j cap plus 0 k cap. And now if you find the magnitude of this vector, then magnitude can be obtained as square root of 0 square plus 4 square plus 0 square, and this will be 4. 4 is not given in these options, and therefore the correct answer is none of this. So magnitude of gradient of a function f xyz square at 102 is 4, but it is not given in the option, and therefore the correct option is none of this. Let us move on to the next question. Find the gradient of a function given by x square plus y square plus z square at point 111. These are the options given here. So we will have to find out which is the correct option. Here, to get the answer, we will have to first find the gradient of this function x square plus y square plus z square, and then we will have to put x is equal to 1, y is equal to 1 and z is equal to 1. So to proceed, let us assume the given function t is equal to x square plus y square plus z square. Gradient of this function is given by gradient of t, that is equal to del t by del x I cap plus del t by del y j cap plus del t by del z k cap. So here t is x square plus y square plus z square. When you differentiate this with respect to x, we will get 2x because y and z are treated as constants. When you differentiate x square plus y square plus z square with respect to y, we will get 2y because now x and z will be treated as constant. And when you differentiate x square plus y square plus z square with respect to z, we will get 2z because now x and y will be treated as constants. And therefore, gradient of t is obtained as 2x I cap plus 2y j cap plus 2z k cap. Now, gradient of this function t at point 1, 1, 1 can be obtained by putting x is equal to 1, y is equal to 1 and z is equal to 1. And therefore, gradient of t at point 1, 1, 1 can be written as 2i cap plus 2j cap plus 2k cap. So let us find this answer in the given options. So the answer is in option B. So here B is the correct answer. Here is next one. If r bar is equal to x I cap plus y j cap plus z k cap and r is equal to magnitude of r bar, then gradient of r is equal to, the options are r bar, r cap, r bar by r square and none of this. Here it is given that r is equal to magnitude of r bar, and we can write magnitude of r bar as square root of x square plus y square plus z square. So now let us find out gradient of this r, that is gradient of square root of x square plus y square plus z square. Gradient of r can be written as del r by del x I cap plus del r by del y j cap plus del r by del z k cap. So if you find differentiation of square root of x square plus y square plus z square with respect to x, we will get 1 by 2 into 2x upon square root of x square plus y square plus z square. If you differentiate square root of x square plus y square plus z square with respect to y, x and z will be treated as constants and we will get 1 by 2 into 2y upon square root of x square plus y square plus z square. And when you differentiate square root of x square plus y square plus z square with respect to z, you will get 1 by 2 into 2z upon square root of x square plus y square plus z square. And therefore, after cancelling this 2 with this 2, this 2 with this 2 and this 2 with this 2, we will get gradient of r as x I cap plus y j cap plus z k cap upon square root of x square plus y square plus z square. This x I cap plus y j cap plus z k cap is nothing but the given vector r bar, and square root of x square plus y square plus z square is nothing but magnitude of this r bar. So here gradient of r is equal to the vector r bar upon magnitude of that vector r. That is nothing but unit vector along the vector r bar. So gradient of r here turns out to be a unit vector along r bar. So this is given in the option B, and therefore B is the correct option here. When you find gradient of square root of x square plus y square plus z square, that is magnitude of r bar here, it will come to be unit vector along this vector r bar. So B is the correct option. Let us move on to the next question. If phi is equal to 2xz minus y square, then direction of maximum increase of the function phi at point 132 is given by, options are 4i cap plus 2j cap minus 3k cap, option B is 4i cap minus 6j cap plus 2k cap, option C is 2i cap minus 6j cap plus 2k cap, and option D is 4 I cap minus 6j cap plus 2k cap. The direction of maximum increase of the function is given by gradient of that scalar function. The gradient of scalar function points in the direction of maximum increase of the function. Therefore, to find the direction of maximum increase of function phi at point 132, we will first find gradient of phi, and then we will put x is equal to 1, y is equal to 3 and z is equal to 2. So let us first find gradient of phi. Gradient of phi is given by del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. When you differentiate 2xz minus y square with respect to x, y and z are treated as constant, and this differentiation will result in 2z because x and y are constants. When you differentiate 2xz minus y square with respect to y, now x and z are treated as constants, and therefore differentiation will result in minus 2y. When you differentiate 2xz minus y square with respect to z, now x and y are constants, and therefore the differentiation will result in 2x, and therefore gradient of phi is obtained as 2z I cap minus 2y j cap plus 2x k cap. Now to find gradient of phi at point 132, let us put x is equal to 1, y is equal to 3 and z is equal to 2. So z is equal to 2, so 2 into 2 I cap, that is 4 I cap, 2 into 3 j cap, so that is minus 6 j cap, 2 into 1 k cap, that is 2 k cap. So the direction of maximum increase of function phi at point 132 is 4 I cap minus 6 j cap plus 2 k cap. Now this is available in option number B, and therefore option number B is the correct answer. This is the next question. If r bar is equal to x I cap plus y j cap plus z k cap is a position vector, and a bar is equal to a1 I cap plus a2 j cap plus a3 k cap, where a1, a2, a3 are constants, then gradient of r bar dot a bar is equal to, the given options are r bar, a bar, 0 and a r bar. In this question, we will first find out r bar dot a bar. This r bar dot a bar will be a scalar function, and therefore we can find gradient of that. So let us find r bar dot a bar first. R bar is x I cap plus y j cap plus z k cap, it is given to us, and a bar is a1 I cap plus a2 j cap plus a3 k cap, where a1, a2 and a3 are constants. So the dot product will be a1x plus a2y plus a3z. So this will be the dot product. Now let us find out gradient of this a1x plus a2y plus a3z. So that will be del a1x plus a2y plus a3z by del x I cap plus del a1x plus a2y plus a3z del y j cap plus del a1x plus a2y plus a3z del z k cap. So when you differentiate a1x plus a2y plus a3z with respect to x, y and z, these are treated as constants, and therefore the differentiation will result into a1. When you differentiate a1x plus a2y plus a3z with respect to y, then x and z will be treated as constant, and the differentiation will result in a2. When you differentiate a1x plus a2y plus a3z with respect to z, x and y will be treated as constants, and the differentiation will result in a3, and therefore the gradient of r bar dot a bar can be obtained as a1 I cap plus a2 j cap plus a3 k cap, and this is nothing but the given vector a bar. So the correct option is option B. Next one, find the gradient of a function f equal to xy square plus z cube y at point 1, 2, 3. So again, here we will first find out gradient of this function f, and we will put x is equal to 1, y is equal to 2 and z is equal to 3, and then we will get the required vector. Gradient of f is given by del f by del x I cap plus del f by del y j cap plus del f by del z k cap. When you differentiate xy square plus z cube y with respect to x, y and z will be treated as constants and the differentiation will result in y square. When you differentiate xy square plus z cube y with respect to y, then x and z will be treated as constants and result will be 2xy plus z cube. And when you differentiate xy square plus z cube y with respect to z, then x and y are treated as constants, so the result will be 3z square y, and therefore gradient of f can be written as y square I cap plus 2xy plus z cube j cap plus 3z square y k cap. Now we will put x is equal to 1, y is equal to 2 and z is equal to 3. So when you put y is equal to 2, y square will be 4, x is equal to 1, y is equal to 2, so 2 into 1 into 2 plus z cube, that is 3 cube, 27 plus 4, that is 31, and here z square, that is 3 square, 9 into 3, 27 into 2, that is 54. So therefore gradient of f at point 1, 2, 3 is obtained as 4 I cap plus 31 j cap plus 54 k cap. Let us find this option in the given options. It is present at option number C. So option C is the correct option here. Let us move on to the next question. Directional derivative of phi equal to xyz at point 2, 2, 2 in a direction of I cap is. The options are 4, 3, 2 and 1. Directional derivative represents a rate of change of function in a given direction. A directional derivative of function phi in a direction a bar is given by a cap dot gradient of that function. So in order to find directional derivative of phi in direction I cap, first of all we will have to find out gradient of phi, and then we will take dot product of I cap and gradient of phi. So gradient of phi is del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. So when you differentiate xyz with respect to x, we will get yz because y and z are treated as constants here. When you differentiate xyz with respect to y, then we will get xz, and when you differentiate xyz with respect to z, then we will get xy, and therefore gradient of phi can be written as yz I cap plus xz j cap plus xy k cap. Now we want to find out gradient of phi at point 2, 2, 2. Therefore we will put x is equal to 2, y is equal to 2 and z is equal to 2. So this is 2 into 2 I cap, that is 4 I cap. This is also 2 into 2 j cap, that is 4 j cap. Here 2 into 2 k cap, that is 4 k cap. And therefore gradient of phi at point 2, 2, 2 can be written as 4 I cap plus 4 j cap plus 4 k cap. Now directional derivative of this function phi in a direction I cap is given by I cap dot gradient of phi. So let us take dot product of I cap and this vector 4 I cap plus 4 j cap plus 4 k cap. This dot product will result in 4 into 1, that is 4. For I cap, the y component and z component is 0, and therefore the dot product will result in 4. So the option A is the correct option here. This is the last question in this session. for scalar point functions phi and psi, gradient of phi psi is equal to what? These are the options given. So let us find out gradient of the product of two scalar function phi and psi. Gradient of products of two scalar functions phi and psi can be written as del phi psi by del x I cap plus del phi psi by del y j cap plus del phi psi by del z k cap. Del phi psi by del x can be written as phi del psi by del x plus psi del phi by del x. Del phi psi by del y can be written as phi del psi by del y plus psi del phi by del y, and del phi psi by del z can be written as phi del psi by del x plus psi del phi by del x. After combining the terms containing phi and psi, we will get gradient of product of two scalar function phi and psi as phi del psi by del x I cap plus del psi by del y j cap plus del psi by del z k cap plus psi del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. This is nothing but gradient of psi and this is gradient of phi, and therefore gradient of product of two scalar functions will be equal to phi gradient of psi plus psi gradient of phi. This is given in option A, and therefore here A is the correct option. Friends, we are at the end of this first session on gradient of a scalar function. If you find this session helpful to you, please like it, subscribe the channel and share with your friends. Once again, thank you very much for watching.